Good morning, IBM and Smartinternz. This is Dr. U. Surya Kameswari, Assistant Professor in the Department of Computer Science and Engineering, Acharya Nagarjuna University. Today, I will give a demo on my project, Effective Heart Disease Prediction using IBM Auto AI Service. So we know that human body is made up of various organs, all of which have their own functions. And heart is one such a good organ. It pumps the blood through the body, or it doesn't do so. So, but nowadays, so based on the main different reasons, so mortality is today's having heart increases due to the heart diseases. Heart disease is also known as cardiovascular disease. In recent times, heart disease prediction is most complicated task in the medical field. So, in the modern days, one person dies per minute due to the heart disease. So, we have to gather the information related to this heart disease. So, we have data science. It plays very important role in processing huge amount of data in the field of healthcare. Yes, the heart disease prediction is complicated task. There is a need to implement a model and to process to avoid the risk associated with it and alert the patient well in advance. The main objectives of my project is, first of all, it reduces the cost of medical tests. To predict the particular heart disease or the severity of the heart disease, we need some different medical checkups. Okay, and here, so it can avoid the helps to avoid the human biases. Lower number of deaths for heart diseases. It provides disease target patient before it going to the particular risk. Here in the existing system, so first we are taking the details from the patient and from the user inputs using machine learning strategies techniques. Okay, so heart disease is analyzed. Okay, so now obtained results are compared with the results of existing models and within the same domain, and it can be found that is that particular heart disease risky or not. Okay, so we have different types of machine learning algorithms, neural networks, decision trees, support vector mission, and live base. Okay, so first of all, we are giving the historical data of the patient to these algorithms. They are implementing some model, and we are calculating the accuracy from those models. Okay, so the algorithm which are giving the most accurate, we are taking that model and applying. Okay, so but not all the models give the 100% accurate results. So in our proposed problem, we present some data processing that enabling working with category variables and conversion of categorical columns. So here we have a predictive model which will be using for Auto AI and IBM Cloud Pack for data. And this model is then deployed in the Watson machine learning service where it can be accessed via some node.js flow. Okay. And here we are using some hardware and software requirements for our project. We require minimum 8 GB of RAM, 64-bit operating system, and Intel at least i3 generation. And come to the software requirements. So we have, we require some IBM services, cloud services, that is IBM Watson Studio, IBM Machine Learning. To implement some programming code, we require Python, Node-RED app, and IBM Cloud Object Storage. So now this is the technical architecture, and here this is the developer. So here the first developer creates an object, okay, cloud object storage, okay, and the same time first of all, it can create a Watson Studio, okay. So after creating the Watson Studio, it created some object, okay. So we are storing our historical data in that object, in that object storage, and and here, so a model is created with Auto AI. Okay, this is the Auto AI. It creates a model. Okay, and uploading some, we are uploading some data in the form of CSV file or Excel file, anything. So here I uploaded is in the form of CSV file. Okay, that is Auto AI is created a model, and this model is backed up, and the data is also backed up on the object cloud storage. And after the model which is created by this Auto AI is given to the Watson machine learning, this service. Okay, machine learning service. And here this machine learning service, after it creates some Node-RED API, it creates the Node.js, and it is deployed on the IBM cloud. Okay, so here this machine learning, okay, through Auto AI creates different models, and from those models it automatically selects the accurate model. And so a user can visit the user interface, okay, or web app of this Node-RED, and enter their information, and he can predict the what is the response. So that is the according to the given parameters, is the patient is in the risky or not. Okay, this is the data set I taken. Okay, here the first column, this is the index column, and here it represents average beats space. Um, next, palpitations per day, and what is the cholesterol, what is the BMI, and heart failure. Okay, here the heart failure 0 represents not risky, 1 represents risky. And age, what is the age of the patient, what is the sex, or male or female. Actually, we have data in the categorical format. After applying some Python coding, we are converted those categorical data into the numerical data. Okay, and this data set is given to the input to the Auto AI experiment. Okay, family history, we are taking the smoker last 5 years, is the smoker or not during the last 5 years, and how per week, how many minutes it can perform the exercise. So this is also important parameter for the patients. So now to create a project, so I'm going to the IBM Cloud Pack for data, and here I created a heart disease. This is my project. Okay, so in this project, I first of all I created some IBM Cloud API key through which I can communicate with the Node-RED application. So these are the assets I created for my project. So here I taken the historical data. This is the patient data V61SSB, and here I created some auto experiment AI, that is the heart disease prediction. Okay, so in addition to those, I stored after running this experiment, Auto AI experiment. So we are getting the some model. So here I am getting the snap voting vision model, and that model is also saved here as an asset. See, so this is the progress map. So means in this progress map, first it reads the data set, and so here after reading the data set, it is divide the data set into two parts: training data and the test data. That is the into 80%, 80 to 20%. So that is given by the developer. And here it reads the training data after applying pre-processing techniques on the means just when I have told that we are converting the categorical values into numeric values. Actually, there is no need to write any code. Automatically, it can convert the any category values are there. It is converted to the numerical data during this pre-processing techniques, processing step. And here model selection. How we select model? Here see, we have the snap voting, mission regression, hyperparameter optimization, feature engineering. So like this, we have different models, and after applying these models, it will complete the. So this is the feature transformers. Okay. So after completing the enter, it selects some particular process. Now see, here we can see the data details also. Okay, here it is converted to 90, sorry, 80, not 80, 90% to 10%. 90% is the training data, and 10% is the test data. Okay, so lastly, after applying the red node user interface, so we are getting the some dashboard like this. So in this dashboard, here whatever the parameters we are seeing in the data set, okay, those parameters are available as a some column, some table. So here we can average heart rate. So we can enter some data, okay, some number by the that is the patient data. Okay, so palpitations, cholesterol, BMI is, so here sex male or female. If you enter M or F, okay, automatically it will take the data. So it treats the M as a 1, F is a 0, and family history S is equal to 1, N equal to 0, like that. Okay, after entering all the data, so click on the submit button, and so it is what the model is, accurate model is created by the auto AI experiment. Okay, so that is applied on the given test data. Okay, so after applying that model, it gives the output that is so based on the accuracy. Suppose see here we have got 0.82 for this patient's data. That's why, so here gives the result as the patient is in the risk position. Okay, so like this, so our project is very useful for predicting the heart disease is risky or not. Okay, thank you, sir. So thank you, IBM, and thank you, Smartinternz. So during these sessions, we will learn so many things. Thank you very much.